Hello everyone, welcome to week 8 live session for the course Introduction to Haskell Programming. I'm Sai Venkakrishnan, PhD scholar from the Department of Computer Science and Engineering at IIT Madras. So this is our final week, the live session for this course Haskell Programming. So the agenda of this session is we'll be discussing any queries you have pertaining to week 7 or the previous weeks, and also we'll just have a look at the week 7 assignment questions, which the due date which got over yesterday, I guess, right? So let's start then. So in week 7, compared to the other week assignment questions, in the week 7 assignment question was pretty simple. It was just a single question. So the problem statement was you should write a program where uh, given the input, you should output should be yes or no based on whether it's a palindrome or not. So for example, if it's like A B B A, then your output should be yes. If it's A B A B, it should be no. So you should check whether given input line of input is a palindrome or not, and that should be given until you stop giving inputs, right, or you exit from the program. So well, everyone was everyone able to solve this question? I guess it's pretty simple. So was everyone able to solve this question? Fine. So this question basically will have like two components. One, you should reading the input from the standard input, and the second is checking for the palindrome. Right. So these are like the two main tasks that you should be doing as part of this program logic. So do you have did you face any difficulties while trying to solve this question? Okay, cool. So in that case, can any one of you share your code snippet? We can have a look at it. If you have your system in front of you or something, can you share your code snippet in the chat message? The code that you submitted on the portal. Okay. Right. So Sagar has shared his code snippet. Import data, okay, to lower is palindrome string bool. okay, clean word, where clean word is equal to map to lower word, okay, right, and the main function is input get contents, let word lists lines input, and let results equal to map of, right, okay, so map of words list, map input string, then results, right, nice, okay, cool. So basically so if you see, look at Sagar's code, he has defined two functions. So one is checking for is palindrome, which is the second task that we mentioned over here. So the is palindrome, basically he is checking, since the string is basically a list of characters, right? So we can use the reverse function on the list of characters on the string, and just check for equality whether given the string, whether it's equal to the reverse of the same string, and if it's equal, then it's a palindrome. And before checking that, what Sagar does is he converts all the characters in that string to lowercase, and once that is done, he defines the main function, it's the start of the control flow when you're entering execution in any Haskell standalone Haskell program, and within that he um, gets the all the input lines, right? He gets all the input lines and stores it in the list of strings word lists, and on this word list he applies a map function where on every word which is part of this word list, on every string which is part of this list of strings, he applies this function. If it's a palindrome, if that word is a palindrome, then it's an yes, otherwise it's a y, else it's a no. So basically, for all the list of words that you are passing, A, B, B, A, or A, B, A, B, you basically applied a map function to this list, this function, and you get a new list which contains the corresponding yes or no, whether it's a palindrome or not. So this is stored in the results list, and this is sort of you again apply a map function, and every character in this results list is printed on the screen using this using this put string on new line character, right? So this is the logic which Sagar has used, and the so this is the correct logic, right? Like this, the only way. It's like sort of trivial. The finding the palindrome or not, I guess you would have uh, done this logic in assignment 6 or 5 itself. The only extra thing that you should do is add this main functionality on top of your palindrome logic. Okay. So, did anyone of you, other than Sagar, face any difficulties in solving this assignment 7 question? Okay. So, in that case, we there was just one question for assignment 7, and we discussed it, and uh, okay, so Naren has mentioned he did not complete the assignment. Okay, so any specific query you have in that assignment, like due to which you could not complete, or it was other reasons that you could not complete the assignment?
No, no. So we had work. Other reasons are there. So I'm not concentrated much on this.
Okay, okay, no worries. So I was just asking whether you had any specific queries which stopped you from submitting your assignment. Okay, cool. That's not an issue. Right. So in that case, so how many of you have enrolled for the final exam for this course, Haskell? Okay, so cool. Everyone has enrolled. Those are okay. So when is your exam in October, right?
I mean Sunday.
Oh, Sunday itself. Okay, 24th. Okay, next Sunday. Right, next Sunday. Okay. So in that case, word of suggestion, like how you should go about like preparing for the exam is try to have a concentrate on the aspects of Haskell, like the main concepts like how the fold function, especially fold L, fold R, right, and then fold R1, all that, and afterwards the map function, okay, and then uh, what other functions, and afterwards the list comprehension, and second, the other important concept is this type inference, right? So given a function or something, given a logic, what's the type of this function, right? So you, based on looking at the logic of the function, you should be able to infer whether the type, what are the arguments of the function, whether it's a function or not, whether it's like a higher order function or something. All these things you should be able to determine based on seeing the logic, right? So for example, they would have just given f1 xyz and some logic. So based on this you should find out whether x is an integer or a bool or a boolean value, or x is a function itself with some type, or it's just some generic type which can be substituted with any type like a, B, or it can be any type, right? So have a look at the assignment questions, assignments 2 and 3, which focus on these type inference. Assume that these type of questions, right? Type inference, and then finding the output given the usage of fold, L, and the fold and map functions, and what's the output of this list comprehension, right? Combining folding and list comprehension, all these um, possibilities, right? So these would be sort of the main things that you should be looking into, right? Because what separates Haskell from your other so what distinguishes Haskell from your normal C or C++ programming are these aspects, right? Like fold, L, and partial functions, and then list comprehensions, type inference, right? Which makes Haskell a beautiful language. So you should concentrate on these things especially, and practice questions, like practice coding basically. So, and moreover, you should sort of know the type signatures of these common functions like fold, L, and map, right? So have a look at that GHCI interpreter, and inspect the type of these fold and map functions, right? Use this colon T, fold, and you will get the fold L or fold R, right? You will get the type of the function. So using that, remember these types, sort of like understand where the parameters are placed. So for example, in fold L, the parameter would be, the ordering of the parameters would be different when compared to fold R. So these things you should remember, because in the exam you will be sort of um, the questions will be like, given a logic containing this fold L or folder, they'll be asking you to key in the output, right? So knowing these type and the ordering of parameters. So in map function, which the first argument and the second argument, whether it's the function which is to be applied or the the list of something, like list of characters or some list, right? So this ordering of parameters you should remember, and also the type signature. So whether it is so for example in map, the type of the list that you are passing can be completely different with respect to the output, the type of the output list, right? It need not be the same. But whereas for some functions, whatever you are passing as input, that the type should be the same type should be propagated to the output also. So if it's like of type int, it should be type int. If it's type char, it should be the same type character, right? So the generic type would be like A and A, like the type signature. So these things do keep it into do remember before you go to your exam, because in the exam you won't be having the interpreter with you. So basically you should get used to these functions, the type signatures, and it should come out of your mind if you just like look at the logic, right? And yeah, that's it. And the other aspect is okay, some so Sagar Bhatt has asked, uh, wanted to ask whether some topics, right? So I'm not sure. So they hadn't asked in the assignment questions, but they might probably ask in uh, okay, AVL trees. It's better if you go through the lecture AVL trees and all those things, because they are part of the course. They had taught these contents, right? So to be on the safe side, I suggest you go through those lectures, and assuming that they might ask in the exam. And will there be programming questions or only MCQs? I'm not sure. So as a student, like when I went to NPTEL exams, there were not programming questions, only MCQs or fill in the blanks. But in the Haskell course, the assignments itself, they had a programming question. So I, I, I suspect there might be programming questions, because I'm not sure of the question pattern. You can post a question in the forum. The TA is pretty active, I guess, in the forum. So you can post a question, but do prepare yourself. Right, there won't be an interpreter, but the um, right, it can be the case like you just have to submit your code. It will just show whether I mostly there won't be programming questions, because I'm not sure how they will judge it, right? Because in the assignment questions, when you compile and run, it shows like test cases passed or something, right? Am I correct, Naren? Or compilation failed or some error messages, which might not be the case in the online exam. I'm not sure, but do prepare for these programming questions, right? It mostly it will be on the same lines of the ones they had asked in the assignment questions. So do prepare for that, and take note, get to know that syntax and that indentation, and the syntax and those things, just have a clear idea, because if at all they ask any programming questions, you should not be taken aback, right? So to be on the safe side, just have a look at the programming questions that they asked in the assignment, and also have a look at the code snippets that the professors had taught during the course, right? The AVL trees or any code snippets, right? So they have taught like an elaborate number of like an elaborate list of code snippets, and like quite useful, like quick sort and all those things, which are quite useful in day-to-day life also. So have a look at those, and once you have a look at those, and what you do, instead of just looking at the code snippets, right? Try to code it yourself, and So um, try to code it yourself and in the interpreter or as a standalone program, and like whatever the code snippets the professor had explained in the video lectures, right? You can code it in the interpreter or as a standalone program and get used to it, right? Instead of just looking at that code snippet. So once you code it yourself, right? You will have a better idea of where you might go wrong or all this stuff. Okay, so Narayan has mentioned. Okay, cool. So the TA has replied. They will notify the structure of the exam once they receive clarification from the instructor, right? So then, based on that announcement, you can prepare. So, not sure when the announcement will come, but if you start preparing now, right, you can, as I mentioned, this type inference, list comprehension, and this map fold, the abstract data types, and yeah, these topics are essential. Like for definitely these topics would be asked in your final exam. A chunk of questions will be with respect to finding the output using fold L or finding the type signature. So that I'm sure. And uh, be prepared so you can go through any books that for example in the discussion forum, the TA had mentioned a couple of books, right? In one of the questions, any external resources to study Haskell from. So he had mentioned a couple of books. You can pick out any exercises or uh, uh, with respect to this type inference stuff from those books and work out those exercises, because uh, personally I knew a student like uh, a couple of them, they had taken the Haskell exam previously, and main questions were coming from this type inference, most of the questions, and they sort of found it slightly tricky also, right? If you don't practice it well. So I suggest you concentrate on these topics first, give it first priority, and second priority give it to these programming assignments and all those stuff. Like once the announcement comes, right? So I guess this should be sufficient for you to score good marks in your final exam.
This exam also will be for 2 hours, sir.
Uh, the timings I'm not sure. The duration, I guess it will be part of your hall ticket. I guess you, once you get your hall ticket, you get the details. I guess. Okay, like so, yeah. And and another suggestion is when you go through these books, right? Especially go through their exercises and you Google out if you don't know anything. Like you can easily Google out and find, because Haskell has so many excellent resources available online, and try to as I mentioned, right, try to look at code snippets using these map, fold functions and this list comprehension functions, and try to find out the logic, right? So you had a look at the sample questions, the assignment questions. It might be similar mostly, or it might be slightly different also. So I suggest you go through these books and work out the exercises. So usually the topics that we covered during the 8 week course in Haskell would be sort of like the basic topics or up till like the intermediary level topics, right? In most of these books, it will go up till like chapter 8 or 9, right? And you need not go through the chapters itself. You can just look at the index or the table of contents and directly go to that particular section and have a look at the exercises and see whether you can solve the exercise questions. So that would be like a good uh, training for the exam. So this is what I wanted to share about the NSEM exam preparation. Any other doubts you have regarding the NSEM or anything? Okay, cool. So in that case, I have nothing else to add on top of this. This is what the course actually covered, right? Using list comprehension, map and fold functions, type inference. So the course revolved around these topics mainly. So all the best for your exam. Prepare well and do share your feedback of the live sessions whenever you get the feedback form. So yeah. Thank you everyone for joining the live session and all the best for your exams. Thank you.